Hello everybody and welcome. In today's video we are going to be talking about the properties of parallelograms. First things first, what is a parallelogram? Well, a parallelogram is a special type. It's a special type of quadrilateral. Remember, a quadrilateral is a four-sided polygon, and it's a special type of a quadrilateral in that it's defined to have two pairs of parallel sides. And that's it. That's the full definition of a parallelogram. Now, let's talk about what properties unfold from us having these two pairs of parallel sides. So let's go ahead and draw some parallel lines. Here we have a line. Here's another. Okay, and let's go ahead and duplicate this line. Shift it over some. And so here we have a parallelogram. I'm going to go ahead and highlight it in this yellow. Okay, so highlighted in yellow, we have this parallelogram. And let's see what other properties unfold from this shape and from the feature of having two pairs of parallel lines. So you should be pretty comfortable with parallel lines at this point. Parallel lines and transversals and, same side interior and exterior angles, alternate interior and exterior angles, so forth and so on. So let's just take some angle. Let's take this angle here. I want you to notice that this angle is an alternate interior angle with this angle here, and that this angle is a corresponding angle with this angle over here. Therefore, the opposite angles are congruent. So another feature of a parallelogram is that opposite angles are congruent. And you can follow the same logic for the opposing angle, such that this blue angle corresponds to this blue angle, and this second blue angle is an alternate interior angle with this angle up top. So you can see that it works both ways and that the opposite angles of parallelograms are congruent. Also, notice that the adjacent angles are supplementary. If we look up top again at this pink angle, if we look up top here, this bottom blue angle or this blue angle to the right, they are supplementary because either way you look at it, they are same side interior angles. So another property is that the adjacent angles are supplementary. And a friendly reminder that supplementary means they sum to be 180 degrees. And because we have two pairs of supplementary angles within our figure, we know that our total interior angle measure is going to be equal to what? It's going to be equal to 360 degrees. Okay, so these are some properties that unfold just from having a pair of parallel lines. Now let's continue forward. Here we still have our same properties. I'm going to again highlight our shape. Now let's draw a diagonal and see if there are any other features that appear. So I'm simply drawing a diagonal, And notice that this diagonal line is again a transversal for two different sets of parallel lines. And so we can notice that this angle here in green is going to be an alternate interior angle with this angle down here. And we can say the same thing for these purple angles. These purple angles are also alternate interior angles. Therefore, they're congruent. And now what do I want you to notice now? So we kind of have a top triangle. We have this top triangle and we have this bottom triangle. And I want you to notice that two of the angles are the same within our top and bottom triangle. And I also want you to notice that the diagonal is shared. So by the reflexive property, of course, the diagonal is congruent to itself. Therefore, by the angle side angle postulate, we know our top triangle is congruent to our bottom triangle. Now, what's the repercussion of having these congruent triangles? Well, that means the corresponding parts of our corresponding triangles are congruent. Therefore, we know that our top side is congruent to our bottom side, and our left-hand side is congruent to our right-hand side. So another property of parallelograms is that these sides, so another property is that the top and bottom and the left and right sides are congruent. Or rather, the sides which are parallel to each other are also congruent. Okay. Now, any other attribute that arises? Well, let's clean this up a little bit. And let's draw another diagonal. Oops. Didn't mean to erase that highlighted feature, but we'll fix it here in a moment. So let's re-highlight our shape just so we can clearly see it. And now let's draw our second diagonal. Let's draw our second diagonal and see if any more attributes appear. So here, I want you to notice that we have some vertical angles. Those angles are, of course, vertical angles, therefore congruent. These green angles are vertical, therefore congruent. And also, again, remember that this angle here has an alternate interior angle with this angle, and the same thing for this side. So what arises from this? Well, we can notice that for our here, I'll label it again the top triangle and the bottom triangle. For our top triangle and our bottom triangle, they are congruent by angle side. So our top and bottom triangles are congruent by angle side. Therefore, this side length is congruent to this side length. And our left and right triangles are also congruent by angle side. And again, because corresponding parts of congruent triangles are congruent, we know that this third side is congruent to this. So what does that tell us in all? Well, it tells us that our diagonals bisect one another. So not only have we also learned that our top and bottom and left and right sides are congruent, we have also learned that our diagonals bisect one another. I'll say each other. Our diagonals bisect each other. Okay, so these are the properties of a parallelogram. Again, to recap, we know that parallelograms are made by having two pairs of parallel lines. We know that their adjacent angles are supplementary. We know that their opposite angles are congruent. We know that the total angle measure is 360 degrees. We know that the opposing sides are congruent to one another, and we know that the diagonals bisect each other. So those are all the properties of parallelograms. But let's continue forward, because there's also special and more specific types of parallelograms. We have our good friend, the rectangle. And so a rectangle is a parallelogram in which the pairs of parallel sides meet at a right angle. So a rectangle is a special type of parallelogram in that the pairs of parallel sides meet at a right angle. So it's going to have all the same features and properties of parallelograms, but because of this unique feature for a rectangle, that the parallel sides meet at a right angle, it might have additional properties. So let's see if we can find any additional properties for a rectangle. So let's go ahead and draw a diagonal. That was a pretty bad diagonal. Let's get it more down the line here. Again, that's a bad diagonal. Okay. Here we go. So here we have a diagonal. And notice that, again, these triangles must be congruent with one another. Here, this top triangle and this bottom triangle, they are congruent by side, side, side. But let's go ahead and draw our second diagonal. Let's draw our second diagonal. I was getting a little bit ahead of myself. Let's draw our second diagonal. Here we go. Now I want us to focus in on two different triangles, and I'm going to highlight them. So I want us to focus in on this triangle here. And I also want us to focus in on, here, let me change my highlighting color. I want us to focus in on this triangle here. So notice that a side is shared. That's why it kind of changed to a green color. Yellow and blue make green, of course. Okay, so in our yellow triangle and our blue triangle, these triangles are congruent. Now, these triangles would not have been congruent with just being a parallelogram. However, because all these angles are right angles, we can see that our yellow and blue triangles are congruent by side angle side. Therefore, the diagonals are congruent because corresponding parts of congruent triangles are congruent. So with rectangles, an additional property is that the diagonals are congruent. Okay, and this is the only additional property for rectangles, is that the diagonals don't only just bisect each other. That is still true. These diagonals bisect each other, but not only do they bisect each other, the diagonals are congruent. Therefore, these are actually all equal to one another in length. All four parts of the diagonals are equal to each other because the diagonals are congruent and because they bisect one another. Moving forward, we have another type of parallelogram. Oops, I wanted the solid line. Let's change it to the solid line. So rectangles are parallelograms such that the parallel sides meet at right angles. But there's another type, special type of parallelogram, and that is a rhombus. And that is a rhombus. And what's the special attribute? Oops, I'm a little bit in the way. Let's lower this. So what is a rhombus? Well, a rhombus is a parallelogram such that all four sides are congruent. So let me try to get this as accurate as I can. So here we go. This looks pretty good. So again, a rhombus is such that all four sides of our rhombus are congruent to one another. These are all equal in length. So let's sketch the diagonals of our rhombus and see if any additional properties unfold. Now again, a rhombus has all the same properties as a parallelogram. It does not have the same properties as a rectangle, but it has all the same properties of a parallelogram. Okay, so a rhombus will not, the diagonals of a rhombus are not equal to each other like they are in a rectangle. However, let's see if we can find a different attribute for a rhombus. So here we have a rhombus and we've drawn our diagonals. Again, we know from our features of a parallelogram that the diagonals bisect each other. Therefore, we know that this side is congruent to this side, and we know that this side is congruent to this side. And the feature of a rhombus is again that all our sides of a rhombus are congruent with one another. So I hope that you can see with our top, bottom, left, and right triangles that all four of these triangles are congruent by the side, side, side postulate. And because they're all congruent, by congruent parts of congruent triangles are congruent. And so what does that mean? Well, that means that these angles, all of these angles here must be congruent. All four of these angles are congruent. Here we'll call it, up top we'll call it, so angle 1, angle 2, angle 3, and angle 4 are congruent. Now, if all four of these angles are congruent, and we can see that, angle 1 and angle 2 form a straight edge, well, a straight line, the angle measure of a straight angle is 180 degrees. And so if angle 1 plus angle 2 is equal to 180 degrees by definition of straight angle, and because they are all congruent and equivalent, we can divide this value by 2 to see that angle 1 is equal to 90 degrees. Therefore, all four of these angles are equal to 90 degrees. So all of these angles are right angles. These are all right angles. So our additional property for rhombus or rhombi is that the diagonals are perpendicular to one another. And of course, perpendicular means they meet at a 90-degree angle. So all of these angles here are right angles. Very lastly, our last special type of parallelogram is our good friend, the square. I'm sure all of you are familiar with squares. And a square is a very special parallelogram in that it has both the attributes of a rectangle and a rhombus, such that the pairs of parallel sides meet at a right angle, just like it does in a rectangle. And then also the side lengths are congruent, just like in a rhombus. So for a square, it has the same additional properties as both a rectangle and a rhombus, in that the diagonals are equivalent, or congruent rather. I'll say congruent, that's probably a more accurate word. The diagonals are congruent, and the diagonals meet at a perpendicular angle. They meet at a perpendicular. Okay, so let's just sketch this picture real fast so we can maybe more accurately see it. By the same reasons of our rectangle, we can find that the diagonals to be congruent. And by the same reasons of our rhombus, we can find that the diagonals must meet at a right angle. Okay, so there are all your properties of parallelograms. Let's do a very quick recap, starting up top here. So again, with parallelograms, just using the fact that a parallelogram is a quadrilateral with two pairs of parallel sides, we can see and learn that the opposite angles are congruent to one another, and the adjacent angles are supplementary, meaning the total sum of all your interior angles is going to be 360 degrees. Next, we put down some diagonals, and we figured out using angle side angle triangle congruence that the top and bottom sides of a parallelogram are congruent, and the left and right sides of a parallelogram are congruent. Then we went on to a special type of parallelogram, a rectangle. And again, a rectangle is defined to be a parallelogram such that the pair of parallel sides meet at a perpendicular, they meet at a right angle. And with this additional feature, we find that our diagonals not only bisect each other, but they are also congruent. A rhombus is another special type of parallelogram in that all four sides of it are congruent with one another. And whenever we have this feature, our diagonals meet at right angles. So all of these angles right here are right angles. And then lastly, we have our square, which is the best of both worlds. It's both a rectangle and a rhombus. Therefore, the diagonals not only bisect each other, like for all parallelograms, they are also congruent, like for all rectangles, and they also meet at a perpendicular, like all rhombuses. If you found this video helpful, hit that subscribe button, and I'll see you in the next video.